So welcome to this day 2 of the Communications Authority and Huawei Cybersecurity Bootcamp. Today we're going to be catching up on our module 1. We finish it up, then we get on to module 2. So without further ado, let me just share my screen. Okay. I know you're seeing a desktop somewhere, so let me just open this. Confirm that you can see that, maybe on the chat, sure. So okay. I'll try to put the chart somewhere so I can see it. Good, thank you. Thank you for the confirmation. Siaji, Shem, Dennis, Catherine, Reynard. Yeah. Gabriel, I think I'll try to tackle those questions at another stage, so you remind me. Good. So I hope today I'm clearer with regards to the microphone. I chose another camera, so I hope that is good enough. You'll be seeing me look up a bit a number of times. So I'll be looking at the other screen. So, okay. I hope there's nothing that is distracting. Is there something that is appearing black on your screen? Or it's good? Okay, if there's nothing, okay, that's fine, good. I thought the screen, the chat and the participant windows are distracting you. But if it is good, thank you. So let us get on to common network devices. This was part of module 1. You already know that in any network, you're supposed to, they're going to be at different network devices. And the common ones, you know, which ones are they? Which ones are they? You can post them on the chat very fast. They're, for example, okay, that is what I was saying, Abdi. Don't ask me about presentations. Don't ask me about what. Yes, switches, routers, firewalls. Awesome. I can see that. Good. So I can see you're already halfway there with regards to this part. So this is what you're going to be. Yes, you also have hubs, you have the core switch, you have the end devices. So those are some of the devices you're going to be looking at. So obviously, with regards to the objectives of this part of the course, you're going to be describing them. That is what you've already put in the chat. We are also going to be looking at some of the functions. Sometimes there's a thin line between what can a switch do, what can a router do. You ever heard somebody say they have a router which is a switch and a switch which is a router? Where do we draw the line? So then you'll be able to know how to log in and perform some basic configurations. Although I don't know that with regards to time, I'll demonstrate how to install ENSP. But I'll see what happens because of time. I don't want to be rushing. Yesterday, a number of you said that I was rushing a bit. So I want us to move in a pace that is at least conducive for everyone. So yeah, so I'll try to manage the time well. So let's go on to this. So this is a deployment scenario of a campus network or an enterprise network, so to speak, where you're seeing, I believe, let me use a pointer. Good. So what you're seeing here, you're having some things such as zones, where you're seeing some dotted lines, where you're seeing something like this looks like cloud. Okay, this virus, I don't know whether computer viruses look like that. This one looks like COVID. Anyways, we have some employees who are working remotely. That is what is happening on this day and age. Yes, Vincent, I'll do that. I'll try to share. I'll make sure I share. after the class. Then we also have the internet, through which we now, you go through the internet so that you get to maybe the remote branches, and also the employees also use the internet as a gateway as they come to access whatever is in the office. We also have some routers here. We have an anti-DDoS here. So we're going to know what is basically a router. Maybe you already know these. You already know. What is the difference between a switch and a router? Basic. That is basic. It's a very basic answer in layman language. What can you say is the difference between the two? What does this do? What does this other do? What does a switch do? What does a router do? Maybe you can also share it there. Or also, if you want to say it aloud, you can raise your hand. I know some people love just saying it out rather than typing. So I would be happy if you want to raise your hand. I'll be checking that. So I can see Collins, you're saying a switch. Okay, you're moving very fast. Then switch forward data packets within a LAN. Collins, Rogers, you're saying router operates on the layer 3, switch on layer 2, switch forwards traffic using MAC, router uses the IP, unless you're saying switch is layer 2 or layer 3 device, router is layer 3, router forwards packets, how Chariot, switch broadcast messages. Yes, these are some half answers. Router connects extranets, while switch is internet. That is a good way of saying it, Gabriel. Then switch L2, network L3, router performs addressing. Router allows for communication between networks. Good, that is a good answer, Daniel. Switch connects nodes while router connects networks. That is also a good way, Beneza. Switch extends the network. Routers are used for network in the network layer. I think network layer is the layer 3, right? So yeah, we have the physical data link, then we have the network. Switch can perform routing, can't perform routing, that is FE. That is unless they are advanced layer 3 switches. Yeah, sure. Router is an intelligent device that acts as a gateway to the network, while switch is intelligent that understands when devices want to communicate and gives a switch connection. A router directs the route of data. So you're already knowing these things. So you're not going to stay too long. Switch connects the endpoints to a network, which is quite correct, yes. Router works at the network layer to find the shortest path for a packet, while the switch connects various devices within a network. Yes, Kennedy, that is true. Yes, I think I'll pause it at that. You are well ahead on this. So you're ready somewhere. For those who maybe have no idea, just check the chat. The chat, no one has put a wrong answer there. No one has put a wrong answer there. Only that if you put them all in one, you can be able to understand this. So when you're looking at these, this deployment scenario, let me just put my luck like that. I also hope no one has done their video. I saw in the recording there's someone who we had to do the class together with that person. They did their video for quite a while. So unless you really need it. So let's go on. We have, for example, these are zone. These are, what is DMZ? What is DMZ? Whose mic is on? No password. I think no one's mic is on. No one's mic is on, unless I'm wrong. Yes, demilitarized zone. Yes. And what is a DMZ for? What is a DMZ? What is a DMZ for? Like, why do we have a DMZ in a campus network deployment scenario? Why do we have it? For those who have just posted, Bakari, Angetich, Mushiri. Yes, Brian, you say it protects the internal LAN. Protecting the internal LAN acts as a honeypot. Offsite region to use for disaster recovery. Is it offsite? Is it for zoning? What is a DMZ? Accessing an untrusted network, separate network paths. What is a DMZ for? In a network, within a network, within a campus deployment scenario. So according to what I'm saying here, it says it's a physical or logical subnet that separates a LAN from other untrusted networks. It usually the public. They're also known as perimeter networks or screened subnetworks. So yes, exactly, Mary. It is deployed to protect sensitive systems as well as resources. Yes, and it also allows an organization to access untrusted networks such as the internet. So that is what a DMZ is. It is actually whatever is usually put in the DMZ. You can see here there's something called an agile controller. These are usually, one looks like a file server, an FTP server, I mean, and this one looks like another kind of a server. So when you look at this deployment scenario, you realize there's also some next generation firewalls. You're going to see how firewalls have developed over time. You also have some, you see some, these are virtual network. I mean, next generation firewall. You can see it is here. It is not a physical, but these ones are physical. We have NIP. NIP is a network intrusion prevention system or an intrusion prevention system, such as IPS. Just the next generation intrusion prevention system is usually developed by Huawei also. We also have an agile controller within the DMZ, this one, and it is used to automate the network resource control system. And most of the time it is used for access control, which is very important in network, in security, because you want to know who has access to what, and control is usually the work. Most of the time it's also within the firewall as part of control. So it is based on users and applications, and it is usually deployed within the DMZ. So you can take more time on it and see what comes out of that, what you understand from it. And maybe if you have a question, you can also ask in the chat with regards to it. So you've already defined a switch. So I'll not take too much here. You already see it works in the data link layer. In short, we just say it works in layer 2. And the work is mainly to forward data frames. And you can see in this example, we have 3 interfaces. You have G001, G002, and G003. And you can see all of these end devices, these workstations, the host A, B, and C are connecting to different interfaces within a switch. A switch can be in different number of ports. We can have a 12-port switch, a 24-port switch, a 36 or a 48. The higher the number of ports, obviously the more expensive that switch is. So yes, okay, I can see Will, you're asking a question. Are the IPS, NIP, IDS, or the next generation firewall in the DMZ zone? So let me just take you back there. You can see the NIP is here. It is within a zone. You can see it is, these are switches, right? These are routers, these are firewalls. Okay, I think these are hubs also. What is this logo? Because I know these are router, these are switch, right? This can be a hub or something, but most of the time behind a firewall usually have also routers. So when you're looking at this, you can see the NIP is this within this zone. It is not a DMZ. The DMZ is here. Yeah, it's called an aggregation switch. Thank you, Shadrach. So it is actually aggregating the network that is coming from these other switches, the switches that are connecting to the end user devices or the end devices or the nodes. So you can see that there's also this like a data center. You can see when you see here, this is an office. Maybe you can think of it like a department, then another department. Then as you head towards the internet, we have some DMZ, and also we have some anti-DDoS. You're going to see more about the threats, as well as what you can do with the threats. So yeah, so it's not typically deployed in a DMZ because it is supposed to be in the front line. It's like asking, can you put a soldier within the safest chamber in a palace? No, the soldier must be out there fighting the attackers. Yeah, so yes, Maureen, NIP stands for Network Intrusion Prevention System, right? So it's called Next Generation Intrusion Prevention, And then VNGFW stands for Virtual Next Generation Firewall. So yeah, so that is what they are. Then this one is an agile controller. So let's not take too long. So always remember that it's a typical switch works at the layer 2, although there are some advanced switches that can also work in layer 3. They're a bit advanced, and they're also more, what can I say? They have more capabilities. That is why they're able to operate at the layer 3, which is the network layer. Always remember that you're going to see the working. You can see how does the forwarding. So in terms of forwarding, it can be in the matter of flooding. So this usually happens when the device that is sending, for example, the one that is here, doesn't know where it is supposed to send. Maybe that it is not in the MAC table, doesn't know where the MAC address for each and every device connected to these interfaces are. So it sends an ARP request to all the interfaces within the switch. And then obviously once it gets a response, it will know where it's supposed to send the data or packets or the packets to. So once it knows, it will actually now forward the packets to the exact interface where the correct MAC address that is there is. Kakasa, I think you can get the link to the meeting. Somebody can share that with you. Yes, ARP stands for Address Resolution Protocol. Yes, we talked about it a bit yesterday. I know I went a bit faster on it. So there's usually an ARP request so that you can be able to fill the MAC address table. So then again, sometimes you can have a packet that is supposed to be sent, and once it is not when you look at the interfaces, where it's supposed to go is not there, that packet is usually discarded. So most of the time forwarding happens in terms of flooding, in terms of there's no knowledge of where it's supposed to go. Once it is known, forwarding is done. And if the packet doesn't have a destination, it is usually discarded. I hope that is clear. If there's a question there, you can also post it on the chat. Then let's look at some of these, what happens here. This is the initial state of the switches. How does it usually look? And when looking at the initial state, the MAC address table is usually empty. It's usually empty. Then what happens is a host sends requests. You can see that. You can see each and every host. This was in also in the other diagram before this slide. The hosts are all connected to their different interfaces. In easier way, you can say they are connected to different ports on the switch, which have these identifiers, the 01, 02, and 03. And you can see their IP addresses. For example, the host A is within CIDR notation. You can see it is taking the first IP address .1. This one is taking the second one .2, and this one is taking .3. All of them within the /24 subnet. So if you really want to understand more about subnets and subnetting, get to understand about the class A, the class B, the class C, you can follow it up with regards to this course on it. And also the concepts is the same regardless of the vendor. So kindly get to know it's a very important thing, because you wouldn't want to have a stadium and you're giving people there and you want to put offices and you don't know how to partition and make offices. So that is what it means when talking about subnetting. So this is how it is. The initial say the MAC address table is usually empty. So what happens is this, there's usually a destination MAC address is usually in that request, there's usually a destination MAC address, a source MAC address, and an address resolution protocol request that is taking place. Okay. Oh yeah, you're taking notes. Sorry, Denzel. So maybe if okay, I don't know where you are, but yeah. So if you're having a question and if you are taking, just take the shortest of notes. Take the shortest of notes. So that we are able to move a bit faster. I know you understand. You also, it's important to take notes, and I agree with you. So if you're also taking notes and you're somewhere you're writing down, yeah, I'll try to move with my pace. So yeah, so what comes first when answering that question? Is it flooding or the discarding? Or rather, how do you know when to answer with flooding or dropping? That's a good question, Maureen. So when you're looking at these, obviously the first thing that is coming, because you're looking at it here, is we'll obviously do a flooding so that we know, is it really, is whatever you want to send, because obviously it will only do flooding when the MAC address table is empty, or it doesn't, all the interfaces have not been, the switch has not learned what devices are there on all the other interfaces. But once it has learned and realized that that packet has nowhere to go, it simply discards it. But if it knows where it is supposed to go, it actually forwards it. Maybe Denzel, you want to add something on it? Maybe you can raise your hand, then I unmute you, Denzel. You can raise your hand so that you appear on the top. You don't know. So there's a reaction button somewhere. But let me just look for you.
Hello.
Yes, Denzel, go on.
Yeah, I hope you can hear me.
Yes, I hope everyone can hear you also. Yes.
So I think I have understood something on the flooding and the forwarding and discarding on the switches.
Yes, please.
Flooding, I think, would mean flooding would mean when the switch doesn't know where to send the packet. So now it tries to find from the other switches or the other nodes which one is responsible or which one should receive that packet, and then now it forwards. Now the process of sending the packet to from one switch to another, or yeah, across the switches, now I think that is what is being referred to as forwarding. So it can forwarding can either be after flooding or just directly when the switch already knows the MAC address. So that is also forwarding. And then now discarding is when the MAC address is not known. I think that is what I've gotten from the forwarding in on switches.
Yes, you're absolutely correct. Thank you so much, Denzel, on that. Yeah, yeah. Yes, we really need to have that interaction, and I hope Maureen, you are getting it. Maybe if you can confirm on the chat if you've gotten or if you have a question on that. Yeah, we don't want to really rush it. It's important to get these concepts well, so that even when you get into how security you get. Yes, Denzel, you have a question you can ask. Okay, you've muted yourself. I don't think you'll be allowed to unmute. Let me see.
Yes, thank you. Sorry, I thought I would unmute automatically. So my question is, why does the switch get to use a MAC address and not just an IP address for the other switches?
Okay, that's a very good question. We already said switches work at layer 2. At layer 2, we're not dealing with IP addresses yet, right? IP addresses are working at the network layer, which is in layer 3. So at that point in time, obviously, they actually also realize that the switch is working with what we call a MAC address table. But in a router works with an address kind of a table. It also has some IP addresses, and it deals with that at that level. So when you're looking at the difference and you're realizing that, and you understand that switches have a MAC address table, that is why you're actually dealing with MAC addresses. And you can see MAC addresses are tied are actually being appended with the request. You have the source MAC address. Yeah, we have the routing table in routers. Yes, yes, Brian. Yes, 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 yes. I hope Denzel have answered you. Yes, okay. So can you allow me to move on from this? Okay, thank you. Yes, Maureen, we answered your question. Were you there? Were you on, or maybe you lost connection? I don't know. Yes, we answered your question, but yes, we really answered your question. We did our best. Even Denzel came on board to answer that. So let's go on, Godfrey. I'd say we've gone on. So if you missed it, the good thing is it's going to be back on YouTube, so we don't have to really repeat it, so that you don't spend too much time there. Okay, so we said the initial state was this: the MAC address table is empty. So the switch records the source MAC address, obviously of the corresponding interface of the received data frame in the MAC. So you can see when a host usually sends that data to, maybe host A is sending data to host C, what happens is that it will do what? It will actually send out an ARP request, an address resolution protocol request, obviously. Then the destination MAC address is usually what we call the broadcast kind of an address. And the source MAC address is the MAC address, obviously, for the host A, which is actually the one intending to send a packet to host C. Please don't do annotations. Please, let's not try to use these features right now. I don't want to really have to set up a lot in terms of security. Let me just, okay, let me just now put a lot of security measures. Okay, we go on. I've disabled annotations for people so that we don't have to see weird drawings. God. So what was I saying? After the receiving the ARP request, this switch, where it is called SWA, switch A for in short, it adds the mapping between the source MAC address and the receiving interface to the MAC address table. So you can see it knows that, okay, this is the MAC address. You can see the MAC address for host A ends in 04AA. It is here, 04AA interface 1, if I could just put it in short. Then what does it really do next? The aging time for the MAC address entries is learned by what we call is usually around 300 seconds by default. So you can see, so these entries are actually, they actually have a time when they get too old in the MAC address and they're removed. So you're asking what is the difference between the interface and the MAC? So the interface, you can see, like, think of it like this switch has let's, for example, say it is a 3-port switch. So having 3 ports, it means that it has 3 interfaces, right? Just as an example, there's usually not 3 switch ports, just as an example. So the MAC address is usually a unique identifier that is usually tied to the network interface card for that device, for that endpoint device, be it a mobile phone, be it a computer, laptop, or a desktop. So that is the difference. So if switch A receives the data frame again from host A within the aging time, the switch will update the aging time of the mapping between host A, and it will continue updating it. Like, for example, the aging time, as I've already told you, is 300 seconds within that X7 series within the Huawei. Then, so switch A will forward the frame through the interface 1. And you remember, what did we say? Let me take you back a bit. When we actually send it, it is not flooded also to the same interface, to the same sending interface. So it goes to all the other interface that you can see. You can see this one is the arrows are pointing downwards. So that is also something else to note. It does not send it back to itself when it is actually doing the broadcast. So what is happening? What is happening after learning the MAC address? There's also the forwarding of the data frames. So what happens is, when you look at this example, the destination MAC address for this of the ARP request sent by host A becomes a broadcast, which is a broadcast address. And then the switch will broadcast the ARP request to who? To host B and also host C through the interfaces 2 and 3. Let me just, for short form, I just say interface 2 and interface 3. I can see Lotengan, you're saying, I've encountered a scenario where host C learns the MAC address of A, but ping is not successful. What could be the issue? So the easier way to actually sort these out, you can use a traceat. You can try to trace how the packet is moving through the hops up until the destination, and get to understand at what point is the packet being dropped. So that is the reason why there can be something that can be an issue. That is why the ping is not successful. For example, it has already learned. Maybe the end device is not on. You can imagine 300 seconds is like 5 minutes. So maybe the time it learned, the host was on. By the time you are doing the ping, maybe the host is off. So yes, Denzel, you're saying I posed you on to ask something. Maybe you can ask on the chat or something. Yes, gift, good. In layman term, the interface is the same as the port number on the switch. That is true. Okay. Oh, you're making notes. Sure. I'll try to also do a bit. So please try to make very short notes so that we also move a bit faster. We are really going slowly. I can see. I think you're also about to get to 4 p.m., which means our time is flying. Okay. Good. So let's go on. So I hope Denzel, you're also making. So you realize what is happening here. So you can see the destination MAC address is, okay, you can see what happens here. The API request sent by host A is the destination MAC address is a broadcast address. This is the broadcast address. You can see when you see FFFFFFF, that is a broadcast address, right? So what happens is the switch will actually broadcast the ARP request to host B and host C. So why is it the broadcast address? Because it's sending to all the other hosts within that network, so that it can be able to know where does host A really want to send, and also try to learn and also add the other entries onto the MAC address table. So can you go to the other step? Maybe you can go there. Yes, you're going to get the YouTube link, Brian. Also, you're also going to get the notes, Kaisi. Yeah, please, let's not ask the same questions every time. That is obviously going to happen. Then what happens here? The reason why you are spending a bit of time here, it's very important to get the basics. I usually say, try to look at the videos with the most views in YouTube. They are not the ones with the most advanced setups, or you're trying to do a number of technical things on YouTube. Try to see anything for beginners, how to do this, very simple startup setup. They're the ones that have the most views. Why? Because most of the time, it is not the beginners who are watching these videos. There are people who have actually done a lot in the industry, but they fail to grasp the basics. So they have to go back each and every time to watch and try to remember the things that they didn't grasp well. So please, if there's anyone who is so advanced and you're seeing I'm spending too much time here, please try to see whether you're grasping these so that we can move. So yes, namesake, we are moving on to the next step. So, oh yeah, Nicholas, you have a question? Please, if it's possible, put it on the chat so that we spend a little time opening it up. There'll be a Q&A session. So where if you want to unmute at the end of the class, we'll do that so that we don't waste the time of people, which is very precious in this day and age. Okay, let me open something here so that I sort some things. And also, if anytime my network drops, you tell me, please. You can see my network was saying it's a bit of unstable, but it's okay. Okay, let's go on. Just curious, we know a MAC, we know how a MAC and IP address look. How can you distinguish an ARP message? That's a good question. ARP message, how does it really look like? Let's open it here. I would like to use a diagram. So that is why I'm looking at Google Images, not that I have no idea. So this is a good one. So this is how an ARP message or an ARP request would look like. You can see there's usually the hardware type. These are the number of bytes it takes, 2 bytes. Protocol type takes 2 bytes. There's one for the hardware address length, the protocol address length, the OP, the sender hardware address. The sender hardware address must be the MAC address. Then the sender protocol address, the target hardware address, and the target protocol address. So this is how it would look like. And in terms of how it would actually be appended, it will be something of having a header as well as a trailer. So so it is usually sent in terms of a request that goes in terms of a message. So it's not like something that you're going to, let me see whether you can get okay, this is the format. So let me just show you an example. This is the format. Let me show you. Somebody is asking about how it looks like, which is quite good. It's very curious. Curiosity is a good thing in tech. So this is how it looks like. You see, this is a good one. So you can see. So let me run a CMD. I don't know if I can do this, a bit of a demo, a small demo, because you've asked for it. Can you see this command line? Can you see it? Okay, let me, yes, Edwin. It's very important for, people, we are going to move faster now. Nikianza kwenda mbio msipige kelele. So you have this ARP, you can see I've done an ARP all, you can see. I can be able to just see this is an interface. You can see one of my interfaces. It has the internet address. These are an ARP request. I've seen some of the ARP, some of what is there. And you can see there's a physical address. You can see some, which are the static ones, which are the dynamic. So that is how it did really look like. You can just run that command also for yourself. Nikienda na hii gear tutamaliza saa 6 usiku. Denzel. So that is it. So let me go back to the slides. Mouse yangu inaamua kumurife hapa. I'm not seeing it on this other screen. Inaamua kunitoroka. Is it good? Imekuja. I don't know whether why a mouse becomes actually a mouse or a rat. I think that is why it is called like that. So if somebody is asking, and I'm just wondering, Marge is saying, yeah, good. Yes, Maureen. It consists of almost everything. I'm just wondering, while the data frame is being broadcast to all the other hosts, how to find the intended receiver, does all the F's broadcast address, all F's. So you can see what happens is here. Do you see this F? Think of it like you're giving somebody a blank check. Think of it like a blank check. Then you're telling them, give it to people, let them write the amount they want me to give them. And then you, when the blank checks come back, you know, huyu mwenye aliitisha aliniandikia check ya 500, najua ni ule. Huyu haizi fikiria mbele ya 500 shillings. Huyu mwenye ameniambia ni mlipe 10,000. Huyo ninajua ni huyu and huyu and huyu. So that is basically how it is, so that umepea kila mtu, so that hakuna mtu atajua ati ni nani. So by the time they receive they receive the request back, you'll be able to know, okay, huyu imetoka kwa huyu and huyu imetoka kwa huyu. Just to give a layman real life example. So this goes not as 11 Fs, but as a whole MAC address that is kind of F. Think of it as blank, right? Yeah. So that is that. Let's go to the others. So what has happened here? It has been broadcast. So once it has been broadcast, the switch unicast the reply from host C to host A based on the MAC address table. So what happens here? So after it has received the ARP request, host B and C query the ARP packet. Host C processes the ARP request and will actually be the one to send the reply. Because of what? Because what happens is, when you look at the other one, you can see the source and the destination. Host C will actually, host B will not reply. Why? Because the destination MAC address of the ARP reply is the MAC address of what? Host A, and the source MAC address is host C. So what happens is, because host A intended to send data to host C, so it will be the one to reply and say, okay, I'm the one you want. So tell host A that I'm ready to receive whatever they want to send to me. So it will be added to the MAC address table. You can see it. In the other one, it was not there. You can see right now, you can see know that host C is connected to interface 3 or port 3, if was to say it in better terms. So that is, once it has done the response, you can see now, once the switch has already done that, the next thing, once host A is wanting to send to host C, it will just forward the packets. The switch will only forward the packets up until it is finished. So that is how it really works with regards to the MAC address table, and it's quite typical, and you can see that. So let's move on to the router. And when looking at the router, you'll always see that it works in layer 3. That is the network layer. That is, you can see. You can see here there are three layers. Yeah. So what happens is, when we talked about encapsulation and decapsulation yesterday, so host A is sending something, it becomes encapsulated, goes to the physical layer, right? Then once it gets to the router, you can see router A, this router A, router B, router C. Router A will take it, decapsulate that packet up until to the network layer, because that is where the router operates from, understand where it's supposed to go, then again encapsulate it, take it back to the physical layer, gets to router B. Router B also again decapsulate it, right? To understand, like decapsulate, just know it's like breaking it down, breaking down the packet, getting to understand where it's supposed to go, then again encapsulate it, that way up until it gets to host B. Remember, if you are sending something from the US, or maybe a data frame from the US, it doesn't go through one router. It goes through several routers. That is the expense. So what is the function? To just forward packets between different networks. This router might be operating in a different network, up until it's, and this network is also where host B is, and goes to that. So somebody is asking what? Why did host B respond to host A? That's where it is confusing. So when talking about host B connecting to host A, maybe you can look at that after the class. You'll remind me so that I don't go back. Is there timeout for the connection between the two switches? There was one switch in the explanation. So so there shouldn't be any. For example, like, a timeout happens when when you are doing a request and they do not get a response within the required time, so you get a timeout. So that would only happen when that host has not replied. Sorry, I meant host and not the switch. Okay, yeah. So there can be a timeout depending on the timeout period, but that doesn't really mean that maybe there's no communication, or maybe it needs to be, the switch might need to relearn the MAC addresses from there. So yeah. So how do router find the shortest route to transmit? So there are different protocols. For example, you have OSPF. OSPF is the Open Shortest Path Fast Protocol, OSPF. So they usually use that, and usually use like weights. Think of it like a diagram. There's usually some algorithms. For example, like there's one called the Dijkstra or something of that sort. So there usually some weights given to certain routes depending on the amount of load that they have. So try to look at it also. You can try to look at it further and see what is there with regards to the OSPF protocol. So you can see this is what you're asking. The router selects the optimal path for packets, then forwards the packets. So that is usually done where you actually see in terms of just to check the optimal path. And if multiple paths exist, the router determines the optimal next according to the calculations specific to the protocol in use. So that, for example, one of the routing protocols is OSPF. So I'll not spend too much time on that. Okay. So with regards to the firewall, think of it, look at this diagram. It's a very interesting one. So we are having different network areas. So the work of a firewall is to protect one area from not only the internet, but also from other areas. For example, let's say there's a rogue employee in this branch and they want to do something malicious. They have already done something malicious, or they already done some hacking within this branch, and they want to do it in maybe, let's say, the production area or the headquarters. They'll not be able to easily do it because of what? Because there are also other firewalls here. So so you remember one thing here, that firewall is used to protect one network area against network attacks and intrusions in another network area. So it has some things such as isolation and defense capabilities, and usually applied on network borders. And it's also used in terms of isolation of different subnets, and also in terms of data center borders. For example, you can see this data center has been isolated. There's also isolation of the enterprise intranet management and control. But we'll see something here. We'll have some nice questions, some coming ahead in another slide here. So yes, Ebenezer, there are protocols to determine the shortest route like OSPF. You're correct. So how do we compare firewall switches and routers? We say there's a thin line between switches and routers, especially when they're usually those hardware devices that perform a dual role. Think of it like that what we call a router in the house that has some aerials. They also can act like a switch, but is it a switch? Usually call them wireless routers, but also you can use them because they have like they usually have 3 or 4 ports. So what do you think about that? You can tell me, what do you think about that? Is it a switch or is it a router? That usually find it in your house. So the primary function of routers, switches is forwarding, whereas firewalls is controlling. So remember this, routers and switches perform one main function. It's only that the area and domain of control for switches is different from the domain of control. I mean, the domain of function is different for switches, and the domain of function for routers is different. So Evans is saying all routers are switches and not all switches are routers. That's quite true. That's true. That's true. But it's quite, it's not that typical. It's not that too general, because you might have a router that has been configured in a way that it cannot even act as a switch. Remember, routers are working in layer 3, right? So unless it is really well working, I've never heard of layer 2 routers. But yes, you're talking about integrated routers, yeah. So let's look at this. We have an aggregation switch. You can see here, thanks to one of us who explained this icon. So you can see it is used to build the LAN, layer 2 and layer 3, and also fast forwarding of the packets. So you can see that. So also these devices are having these, and then these all within the switch, forwarding the packets within the LAN, local area network. Then the firewall, before it gets to the internet, it is the work of the router, and it's the work of the firewall to control how the packets are forwarded, and also to deal with things such as and things with Trojan horses and also viruses, uses some ports, control certain requests. that is the work of the firewall. And the firewall can be a hardware, and also it can also be in software. But for this case, if it's not a virtual firewall, you can see it is a hardware one. Then you can see these R means routers. So they are usually used to forward packets between different networks, and you usually see network interconnection. So that is it. So when looking at what of access points, are they switches or routers? That is the Wi-Fi extenders. So Wi-Fi extenders, they actually amplify the signal. I wouldn't say that they actually do the work of a typical router, of course, but a router, yes, can be configured to be an access point. That is true. That is true, because you've ever seen those routers that have even a port to put a modem. So they're what? So yes, Denzel, yes, they're amplifying the signal. They're actually boosting the signal so that it goes further or reaches every part of a building. So from the diagram, the one that, at the bottom is a core switch. Those above are aggregation switches. Yeah, so these are the aggregation switches, right? And then this one is a core. Okay. Okay, Frederick, yes, we can agree. Obviously, you're also here to learn from each other. That is, so you can think of it like this is a core switch, because obviously it is a core switch that has usually a connection also to the firewall. This is very true. Anytime in any enterprise, usually have this core switch and usually configured in a different way from the other aggregation switches, and is usually a bit more protected in terms of its security, because when you're actually able to look at even the ports, you don't just have typically empty ports lying around, or open ports or open interfaces lying around in a core switch. So yes, you're correct, Frederick. So this is how firewall developed over the years. They started out with just packet filtering in 1980s. Then there was some proxy technology. Then there's some session mechanism that came into play. Came 1995, became a dedicated device. Then come 2004, fast forward, we had unified threat management, where you're having some several functionalities put into one device, and you're having it in terms of managing intrusions, managing viruses, managing traffic. Unified threat management. You can get to learn more about it on Google. Then come DPI. What is DPI technology? Then you also have control. Now, next generation firewall is what has now become the in thing. Well, now you are now having control that is more granular, more detailed. You're now controlling even content. You're also controlling the user and even the application itself. So this is where we actually are getting to. So that is how it has really developed over time. So look at this. Firewall has usually a security zone, or just called a zone, a local or a logical security zone. Then we have a network connected on to one or more interfaces. So we have, let's say, we have usually what we call, in terms of functions of a zone, we have policies are usually implemented based on the zone. So for example, whatever policies are applied in a DMZ are not the same security policies in a trust zone, and also in what we think about in terms of the untrust zone. So the firewall will always do some checks and implement security policies when data is flowing between, for example, when data is flowing between the untrust zone to the DMZ, it'll actually do some checks, even on the user, on the application, as well as the content. When talking about that. Some of the default security zone in a firewall, this is very important, because when you're going to be doing a lab, and even for those who are going to be having the opportunity to go and do the lab hackathon, maybe in Naivasha, you need to understand the concept of the firewall very well, especially the Huawei UGFW firewall, how to log in, how to configure dual hot standby, and so on and so forth. So we usually have the 4 default security zones. That is the untrust zone, the trust zone, the DMZ, and also what we have called a local zone. So we have some brain teaser somewhere. Time is really flying. Damn, I have like almost around 10 minutes or so, and I haven't done this, haven't moved as fast as I wanted. Anyway, we'll see how we look at. Remember, as you're taking, we'll see how we can move with this. Okay, I'll be sending the attendance. I'll be giving you the attendance in a few minutes, so that obviously people who are actually going to be having some issues with network going forward, they'll have already been having peace of mind that they've filled the attendance. So I'll be doing that over the break, so that I'll give you time, you have time to get off the call to just fill that attendance, just your name and your email. Okay, so this is where questions are now coming, and I want you to help me understand. So the first question, what you're looking about the relationship between firewall security zones as well as the interfaces. So the first question that is coming here is, does the firewall have 2 security zones with the same security level? Maybe you can tell me. Can a firewall have 2 security zones? Think of these as security zones. 2 security zones with the same security level. Can that really happen? No, that can't happen. True, that is Edwin, Major, Gift, Eddie. Yes, that can't happen. Because why would you have it? Why would you have it have the same zones having the same security level? It doesn't really make sense. They're not. So yes, it can't really work. Why? And somebody may be asking, why can't we have 2 zones with the same security level? Because why? The firewall, we've already said, will actually do some security checks as data is moving between the different security zones. So if there's same security level, that is already 1 zone. So not 2 security zones. Then we have, does the firewall allow the same physical interface to belong to 2 different security zones? Nope. Yes. If you look at this is an interface, this is an interface, this is an interface, and this is an interface, right? But do you see that this interface is already in its own, let me call them bubbles, in its own bubble? This interface is in its own bubble, and this interface is also in its own bubble. So any physical interface cannot belong to 2 different security zones. The firewall cannot really be configured in that way. Then another concept and another important rule that you need to remember is that different interface. Okay, let's answer this first. Can different interfaces on a firewall belong to the same security zone? Maybe you can tell us. Thank you for those who have answered already. Major, maybe. Okay, so this is the last question. Can different interfaces on a firewall belong to the same security zone? Phyllis, I can say you're saying yes. Lynette. There are some people still saying no. Shem, Philip. Kefa, yes. Dicky, yes. Simon, yes. Ellie, yes. Edwin, yes. Jire, no. Willie, yes. Joe, yes. Hilda, yes. Kakasa, yes. Fanuel, yes. John, yes. Steve, no. So, yes, Dominic, yes. And Ian, yes. Okay, I'm seeing the yeses coming through thick and fast. Kevin, Kimtai, Catherine, Claire, yes, yes. Admin, yes. Mary Campbell, yes. So it means, or maybe people are just saying yes because others are saying yes. They weren't sure. Nanga wale watu wanaambiangwa wasimame wanakosa kusimama wakiona watu wengi wamesimama ndio wanasimama na wengine. Anyway, I can see no password amesema no kama jina yake ya kwanza. Why are you saying? For those who are saying no, can you tell us why you are saying no? For those who are saying yes, can you tell us why you're saying yes? If you have an answer, why are you saying yes? Why are you saying no? Because this one inakaa iko hapo, inakaa kama elections ya Kenya. For those who are saying, do you have an answer? They're just saying yes for the sake of it and saying no for the sake of it. Anyone who has an answer? Oh, so that I don't waste time, because naona ni kama hamna answer. Let me tell you the answer. And the answer is in the diagram, obviously. Okay, I can see the illustration shows current different interfaces in the same security zone. Yes, that is also, but okay, because different interfaces will not affect security levels. Yes, because G00 and G are both in the trust zone, but they're different interfaces. Two interfaces can use the same security level. Yes, that is exactly what you're saying. Frederick, you've said it exactly how I would have said it, is that two interfaces can share a security level, and the security level is determined by the security zone, right? So you can see this interface, 00 and this 00001 are all within one zone. Different interfaces, same different zones. So for those who are saying no, always remember that interfaces are not supposed really to be in the same, unless you really want to configure them as such. But typically you can have a couple of interfaces within the same security zone having the same security level. But you always need to be sure of what you're putting in that interface. But because you need to remember that they are going to be having the same. Dev, I don't know why you want to control my screen, but I would refuse to that. So there's a question: if different interfaces belong to the same security zone, does the interzone forwarding policy take effect? There's a question that I'm seeing here. So if different interfaces, like these ones and these ones, belong in the same security zone, does interzone security forwarding policy take effect? That is obvious. It is not going to take effect because it is within the same zone. Also, there's some logins you need. How do you log in to do some basic service configurations and service settings? So remember that there's usually what we call a VRP. VRP is now the platform. Think of it like we have iOS on the other side, but here we have the VRP. VRP stands for Versatile Routing Platform. It is usually there within Huawei routers, Ethernet switches, and also some service gateways. And they're usually used to what? To implement some unified user and management. It provides a unified user and management interface. And also it implements what we call the control plane. We have what we call the control plane functionality, and also define some of the specifications for an interface for the forwarding plane. So think of it like the versatile routing platform. Think of it like like a kernel, or you can think of it like your Android OS, but it is an OS that is within what? Within Huawei routers, Huawei switches, and also other like service gateways, something of that sort. So that is it's a platform. Denzel, I hope I've answered you. So it is a network operating system. It is supposed to support multiple types of devices, and also provides what we call TCP/IP routing services. So it's a way you can log on to it. And one way of logging on to it is the command line. You should already be familiar with the command line if you're going to be a cybersecurity expert. because you need to appreciate the importance of the command line. Not all devices, or not even, I've rarely seen a server, a network server, or a Linux server, or an FTP server that usually has the graphical user interface. So it's very important to understand. So within the command line for the VRP, there are different command views. So there's the user command view, the system view, there's interface view, and the protocol view. So the system view, the user view looks like this. This is the prompt. That is how it looks. System view, you will type this command, system view, then it will have, instead of these angle brackets, it will have the square brackets. Then interface view, for example, these are command you can run. You want to look at what is there within this interface, or maybe the subsequent commands you're going to run is going to be affecting this interface. You will type interface gigabit Ethernet 001. Then you're going to get this prompt. You can see this person was about to type quit so that they get out of it. So when you click on, when you type quit and enter, you're going to be taken back to the system view. That is how you can see that. Then when you're taken back to the system view, you can go to a protocol view, for example, OSPF1. So you can see the command, the command prompt changes to ngfw OSPF1. Yes, it looks, yeah, you can see it's like console, but obviously, yes, it's a console in essence. It's a console. So, but when you talk about console, you can think about the hardware and you're supposed to connect to console, for example, in terms of a switch. But yes, so these are the different, you should know the difference there. So user view has the angle brackets, system view square brackets. The interface view will always give the name of the interface. The protocol view will always give the name of the protocol. So you can get some help, some full help. You can type the question mark and press enter, and you'll be able to see some of the commands within the user view. If you type display firewall question mark, you can be able to say display firewall blacklist, display firewall data plane, display firewall defend. That is how you can run it. Although we'll have a session where I'll try to show you some of the things. I'll show you how to install and see these commands. So you can see some partial help. This is the full help. Partial help works like this. You type D and a question mark, it will give you all the commands that start with D. Display B with a question mark will say display B with B and everything that will follow it. Display bridge, display backup configuration. So you'll be able to see that. That is how you can see with that. So when you type the tab key, I believe you already know this. If you are a lover of command line, if you have typed info, then you put a hyphen and you press tab, the tab key, it will add the other part of center. It helps you reduce the number of keystrokes you are going to type. So for example, if you type interface L, then you put a tab, you can see it will show you. So if there are multiple matches, for example, you can see it will try to show you some of the different errors there, and then maybe you can choose. Yeah, yes, IntelliSense, like IntelliSense. Good, that's a good. Yes, these are commands that are running on firewalls. Yes. Oh, my break. We are for, maybe you agreed it's 4:45. Mine Baka 5. So yeah, for those who's asking about the break. So I think I have 10 minutes to go to the break, and that during the break is when I'll give you also an opportunity. Now ukijaza attendance watu ujaze alafu upote, utajua. So you go on. So configuring interfaces, this is now you can configure interfaces. Maybe this is now when you're using the web interface or a graphical interface. So you can see here you're going to change, for example, you can add a security zone. at this point in time, at this place. So when you choose network, then you go to interface. Have we started? Okay, I thought I jumped a slide. Then you can select the interface to be modified, configure the IP address for the interface and the switch, and switch the interface mode. So switch the interface mode. The available modes is usually routing, layer 3, switching, and layer 2, or even a hybrid of them, which is layer 2 and 3. So when you choose the mode, you can be choosing routing, switching. You can see there's also bypass somewhere here. So you can configure the IP address and subnet mask. I hope you already know. If you don't know these concepts, it's very important to look at them. Get to know what is a subnet mask. Get to know about a wildcard. Get to know about the CIDR. Get to know about the dot notation, the octets. Very important to know these concepts. Very basic concepts, but you'll be able to do that. So there's a way you can do this also on commands. So if you get the PDF, you'll see that. So when you're configuring routes, this, I think this is for USG 63330. So you're looking at this is how the interface would look like. I told you I'll show you how to install ENSP, and you can try this out. Yes, Andrew, I'll be sharing the attendance in a few, just a few, like in less than 10 minutes, I've shared it. So network route, static route. So you click on network, then you come. Sasa hiyo nini yangu imepotea. Ndio hiyo. You click on network, you click on route, then you choose on static route here. You can see it is here. Chana na ka rectangle kako in the wrong place, but it is here on static route. Then you'll get this. Once you get this, you're going to choose and make the changes as you want. So that is how you configure routes. Within, I think these are what? This within a firewall, obviously. So what is the overview of device login management? You can log in over the console. You can log in over Telnet. And you can log in over SSH. And also you can log in over the web. So there's usually some serial interface cable. You can use Telnet if you have SSH, and you can even access through a web browser. So when you're using a console port, for those who are ever familiar about this, yes, Dennis Masil, I can see RIP. Okay, RIP, is it connected? It is showing RIP, the protocol, but in this example, you're being told to use the static route, which is where the screenshot shows. Yes, it is here. Network route, static route. Network route, static route. Yeah. So when you connect it through the console port for a physical firewall device, you're going to check the parameters on the device manager if you want, and you can check. So these are process. I'll not spend too much time on this because these materials are there to help you when you come to doing it. So I can't really explain something that is practical using theory. It doesn't really make sense. Then where are we? Configure the connection interface, communication parameters. Yeah, so you can, when you're getting to PuTTY and you are now trying to set up now so that you can access the console, after you've configured it, check the parameters on the local port, you'll use the same parameters here. Then you get to that, then you open, then you access it. So for web login, remember that in the browser, okay, by default, you can log in to the device using gigabit Ethernet 000. And okay, what we will do, we'll use the network simulator ENSP, and I'm going to demo something. I'm going to demo something on it. Putty, yes, you might obviously need to download and install it so that you can use it for a physical firewall, and then you can set it up and connect to it. You need to do that. Okay, we are about to go to break. What time? Oh, we have 5 minutes. So remember this. The IP set. This is how you log in. You set the IP address obtaining. Set the IP address obtaining mode for network to obtain the IP address automatically on the administrator's PC. So what does this statement really mean? It means that the way you are supposed to be accessing the network on your computer, the computer that is going to connect to the web console, should be dynamic. Then you can directly connect to the PC's Ethernet interface directly connect the PC Ethernet interface to the default management interface on the device. So what does this really mean? If you have the Ethernet port on your laptop or your desktop, so that Ethernet interface, you are going to connect it directly to there's also another port on the device called the default management interface. So when you're going to connect to them, you're going to connect them via a switch, not directly to each other. You're going to connect to them via a switch. So once you have that, when you type 192.168.0.1 in the browser, you're going to access the login page. By default, this is the default URL that you're going to get after you do these earlier steps and you type it successfully, you're going to get to this point. Remember that there's this default user logins. You want to try, maybe you'll try it over the break. I'll show you, maybe you can try that out. We'll try that out over the break. So if you want to SSH, you're not going to really SSH if you haven't set up the console. I mean the console, the COM port, because you have to do it. You have to do it first. Then you have to use that. Can you use other figures? You must use those ones. You don't use any other because this is the default. And also these are default unless now obviously, which is very important, you are not going to change them once you log in. But the initial, when you bought a physical firewall, or even you are using the virtual firewall, you're going to be getting as these as the default. Admin, capital A, admin @123. And this is very important because you'll be wondering, unaanza kuniuliza ati what is the password? And we already talked about this. Yes, Joe, you have to configure the serial cable, then SSH. Yes, that is true. So once you log in, you can be able to set up some of the configuration management. You can enable web management function, enable HTTP or HTTPS management according to the requirements. Also, you can set a port number so that you can just ensure that the service is correct. I've already said that this one is the default. Si hata ukinunua simu inakujanga ikiwa, ama ukinunua kitu inakujanga na hata ukitengenezewa password yako ya the email for your institution or maybe for your organization, you're given a default password. Then you're told the first time you log in, it will tell you to change your password. So it doesn't really mean that it's going to remain like that. It is going to be prone to attack if you leave it like that. That is why I always say the human is the weakest link. So I was saying about web management function, web management. So you can do all this. You'll see me, I'll not dwell so much on them because you still do this and try to come back to these slides. Then you can configure an administrator. So Maureen, what you're asking, you can see you'll have to set up a web administrator. So all these are very important. Configuration management. Most of the time attacks happen because of misconfigured devices. So you can do this when you're configuring this. You can also do it using command line. So you can do that, and you can see some commands for when you look at the PDF, you'll be able to see that. So this is the third step of configuration management. You'll configure also the login interface. You can see access management. You can allow HTTP and also HTTPS there. Then when you look about telnet, you can enable or disable it. You can see that. By default, it is disabled in the next generation firewall. But to use telnet to log in into the next generation firewall, you need in another mode to log into the next generation firewall in another mode and enable telnet service. So you can log in and via web, then enable the telnet service. So you can also configure telnet administrator once you enable the telnet service. Then you can also do a telnet login. So you configure the login interface, static IP. You can also define that IP. You are asking about 192.168.0.1, you can change it there. And also you can see that access management for this interface, gigabit Ethernet interface, is allowed to telnet. It allows telnet as well as ping, and you can set all that up there. SSH login, for those who are asking, which is very important for this, you need to enable the S-Telnet service. So you can remember this, which view is this? Somebody can tell me. I mean, I have only one. Okay, it's already time for break. This is the system view, Cindy. So that's how you log in. You configure the management and that. So there are some certain settings that are here. I'll not dwell so much on them. Yes, that is the system view. Thank you, Denzel. So let me just finish up on this module so that tuanze na kitu ingine after the break. So you can see, you look at, so what have we talked about? Overview of device file management. So some of the settings, there's some saved configuration, there's the current configuration. There's usually a configuration file. You can erase the configuration file. You can configure the system and configuration file for the next startup. And also you can restart the device. So that is how you can think about the configuration file types. So when you talk about one-click upgrade, here you're talking about is it really helps you because it automatically deletes the system software that is running if there's no space, and then it helps you upgrade to the latest version. So that is what you can do. I believe you've even done a similar upgrade on your phones. Usually don't really follow it up whether there's enough kind of a space, but the one-click upgrade really helps you with that. So these are some of the steps you can see. You click on system, then you go to system upgrade, then you choose one-click upgrade. License configuration, you can remember that firewalls also require a license. So when you buy a license from Huawei, you can configure the license under license management, system license management, and just choose it. Or you can even activate. Now we are done. Squeeze time. What is the default login IP address for the web login mode? What is the default IP address? Okay, does this apply? Yes, it applies to Huawei, but it's a little bit different when you're talking about other vendors. So it is obviously the first one. Yes, I can see you're really attentive. Very good. Major, Lottingen, Julius, Charlotte, Claire, Gabriel, Alfred, Philip, Reinhard, Brian, Emmanuel, Adonija, Moses, Kinsey, Maraga, Oliver, S ndio gani? Cherotich, Sankuri, Stevie, Nagori, Clarence, Katiku, Karen, David Gadu, Oliver Cheruyot, Fire Hunter, Maureen.0.1 ni sawa kwa unique. Eugene, Denzel, Lavender, Bakari, Chris Mutinda, Frankincense, BLVK, Dennis Seronu, Samuel, John Gitao, Edu, Ude zinaenda mbio sana. Efiwashira, Elias, Dan, Walia, Adrian. Yes. Yeah, you're correct. You're all correct. Elvis. So you're correct. You're correct on that. So we've done a summary that is, okay, I thought we'd do this module in 30 minutes. We have already taken the whole first session, but Nisawa. So that concludes it. You are free to go for a break up until 5. Sorry, I've taken 5 of your minutes. for those, I already said that I'll use the 15-minute session to give you some career. So you can go take your kind of a tea or something. Inatisha kwa baridi, tasizi kunywa. But ni sawa. Okay, let me just pause the recording first. Okay, yeah, also let me give you the attendance. Okay, so we are back. I hope you can see my screen. This time I want to show you a demo on how to, don't worry about it, Moses, as long as you can hear me. I'll actually want to show you how to install ENSP. So I have it on my hard disk. I'll upload it on my Google Drive and share with you. Although I don't know why my hard disk is not appearing, but I can see it's here. So usually have it like this. So this is how ENSP looks like, right? So you can install it if I run this. So what happens? Let me see whether it's loading on this side. I might double click on it, then it appears on this other side.
Time to play around with the new experience, be able to really educate you and help you along the way. You guys can take this journey with us. And as we get into this converged platform, the goal is to take the
to download, don't worry about downloading. I'll just share with you the Google Drive so that it is quite crazy to find it online.
And add that LMS functionality that we have for our instructors. So that's what we're trying to do is it's really around.
So I'm really not sure about the Linux version, but I will try to check on it, Katiku. So kindly confirm that you can see this.
We're going to have you do some different rankings. We're going to have you look at some of the features that we're looking at, show you some of the features that are up there first. So Patty, if you want to go ahead, we're going to give you a link in chat. Sometimes chat is a little harder to find on your cell phone, so see if you can see the chat feature.
So I haven't uploaded it, Samuel, but I'll upload it and share with you the link. Don't worry about that. So it's on my hard disk, so I'll just give it to you later on. Okay, so kindly confirm. Okay, you can see. So the first thing is when you double click on this, you get this wizard. Click on next.
And you'll come in kind of anonymously. Does that make sense? So you should see Patty and I's name, but for the rest of you, you'll come in, since you don't have a full Miro account, you'll come in as basically kind of a generic person or environment.
So you have this.
There's a few things here. All right,
are you seeing the next step?
Yep. And for sure, who is our visiting inventor?
So you can see it is telling me it already exists, but I had installed it for this class. So I click on next. You keep it on the chat so that I can see if there's anything.
Let's see. If you look at the upper right, it should tell you. I think the icon on the far right will say what your name is and put you in parentheses behind it.
Yeah, I'm visiting inventor.
Okay, you got a visiting inventor, and who might be visiting architect? Either Kevin or Ahmed.
I'm
And if
not
you guys
sure.
are having trouble, please feel free to speak up and come off of mute.
I think I'll have to go to the laptop. I'm seeing I'm having a problem. Let me just use my laptop.
Okay, great.
So the next step, let me see.
Yeah, we'll start with just helping you understand the Miro, how to get around. It's very similar to what we used before, where we called the Miro.
But they're slightly different. It's like, well, we can't do the exact same navigation as somebody else, even though we might need to. So we'll talk a little bit about just zooming in, zooming out, and a few of the basic functions, and then we'll get into the actual activity. Patty, we may want to add that to our template. I can't remember reading.
So I go to next. Then I'll click on create the desktop icon. So you realize something here that Godfrey multitasking. No, I'll do this. Sorry about that. Sorry about that. Thank you.
Just wait for one more to join.
So where are we? Where are we? Where are we? Where are we?
Let us know once you have access.
Yes, yes, Rogers, you need to have virtual machine. Am I muted? Am I muted? Okay, you can hear me. Sorry, thank you. So you need to have the VM, you need to have Wireshark and also NP pickup. So you realize on my downloads, when I go to my downloads, I've been downloaded pickup and also Wireshark here.
Yeah, so if you scroll way down.
So yes, you should have all the prerequisites. So how do you download Wireshark? Just go to Google. Go to Wireshark, just download. It's easy, it's very easy. You go to Wireshark, you find it, it's here. You can go to download.
It's the opposite of what you would think, right?
Then you choose the first one, a Windows installer, the stable one. If you're using, I think, I don't know whether there are other installers. You can see there's one for Linux. You can do that. So let me install. Let me install Wireshark.
It looks like Patty, I didn't log in, so of course I'm visiting researcher, so maybe that.
I can see your.
Okay. So just a couple things about the board. As Kelly said, not everything is necessarily intuitive. Just a sec. I'm also going to make sure here I can log in. Can I get it?
So I'll say run.
I signed in earlier. I thought it would recognize me, but
I'll click on next. Then I'll say noted. Okay. I'll install. No worries about it. No other things you need to. You can just do that. While Wireshark is a network protocol analyzer, I'll still install and pick up as part of it if it is there. If I did to install this, but I'll not need to install that.
We are just we are just like half a mile from the map, supposedly, when I looked at it. It still wants me to log in. It's Cisco, I don't understand.
Okay, so it's installing. You can see the page that I'm working on. It is here. I've just clicked on next, next. I just clicked on next, next, next. So it is installing.
I clicked on the link in the WebEx. Yeah, that's the. Okay, there we go. All right.
I don't know why mine is taking a bit of time. So how do you download VirtualBox? Just also go back. You can just Google VirtualBox, Oracle VirtualBox. So I can see npcap is appearing here. So it looks like this. Green. Install. So it is done. So you Google VirtualBox. So you come and download. Sometimes it's better to work with the right version of VirtualBox. If you look at whatever is here, if you look at what is in my hard disk, let's see the version. You can see it is 5.2.4.4. I don't know which is the one which is installed here. So let's look at this. So you can, it's optional, Kenya, if it's installed, it's optional. So where are we? My mouse is not showing. So here is my VirtualBox. Yes, I am. I've done something. I think I'm a builder. Okay. I think I'm a builder. Yes, I've put something on the second goat. Okay. So when pick up VirtualBox. Which other file? Which other file? Oracle for the lab. So, okay, this is not the devask. Let me just put this. I was just showing my Android. It is 6.1. So let me see whether I can install this other one. So we have this. So I'm installing Matrobox. What else do I need to install? So let's see. Yes, you can run it on Linux. NSP can run on Linux. You can check on that, but you can follow it up. So it's running. Let me do the chat somewhere side so that I can see it. Yes. Yes, Frederick, that is a good, a reliable source. I've clicked on it. So where are we? Sorry about this. Just minimize everything. Installing that. I'm good. I'm good. I'm good. So it is here. So the next thing we need to do, Wireshark, I think, is installed. You can see it here. Wireshark is installed. Yeah, she reboot later. So uh-huh. Sharon, acha hizo. Let's go on. So I've installed VirtualBox. If you look at now the VirtualBox 5.2, good. The reason why you're doing this is because of the version of VLSP. Denzel, we have installed another one. We have installed this one. We've installed this one. Yes, Jailin, you have something? Okay. Oh, okay. So Next. think I'm good. Oh, I think they actually rank within their categories, like second within their categories. Let me see. Second within their categories is like, oh, okay, okay. Yeah, sure. That would be good. Oh, okay. Sure. Yeah, yeah, exactly. Exactly. Uh, Okay, can you see my screen with my ENSP now working? How many have gotten to this point? How many have gotten to this point? Faith, Denzel, have you been able to install it? You can say router, you want us to raise your hand. Maybe I'll do it at the end. Maybe you can do the chat first. So, what's happening? So you don't need to check anything. Dark, you don't need. Maybe you can check the second or the third, maybe if you want. You can check the second and the third. So, okay, let's see where my upload is. I'm good. I think, yeah, I'm good.
Mm.
So can you guys hear me? So this is where you actually get to these are firewall. These have just installed a firewall. You can be able to look at a number of things. For example, you can have a device that can have a switch. Can connect.
And one final question for both of you. It's more that the question banks in our assessments from the chapter assessments, module assessments, and final assessments. Do you think that question banks that we put in so that every exam isn't exactly the same? Do you think that's fine?
You know, like Kevin said, sometimes I'll use different words to explain something versus not competition. When I say words, something I think
So can you hear me? Can you hear me, guys? Sorry, I had to be on mute for a while. The reason for that is I was trying to ensure that I save face on the other side. But since I'm going to reiterate on what to do, there's somebody who was asking something on the chat. Sorry, I know you are going to do this. I know I'm a bit late. We are 15 minutes ahead, but I'm going to just ask for just 15 more minutes of your time. Then we can call it a day. So there's somebody who asked, what is the work of this? Let me share. I hope you're seeing my screen, my primary screen. I decided to share my primary screen. Somebody was asking, what is the work of this, right? It's not finished uploading yet, but it is uploading. Let me close that. So the work of it is what we call the firewall image. I think mine already sorted it out because I had installed DNSP earlier. So when you try to use, I don't know if somebody has tried this. Have you tried to do this? Let me just delete this whole topology. Have you tried to go to the firewall part? Try to use this USG 6000V and open it and try to double click it. Does it really show this? I'm sure it doesn't. Maybe if somebody has done it before using the image, that is. Before using the image. Has that happened? I hope you're also following. That is why I was actually due to install this. That I've actually left the notes a bit. Notes, notes, you're going to read all of them. You're going to read the notes. You're going to have them. The essence of these live sessions is to make you ready. No, it's not opening the CLI. Yes, Effie. What is it telling you? Can I give you the ability to share your screen and see what is showing? Do I do that so that you can see what is happening on your end? Adonija, okay, you are saying yes. Are you saying yes on behalf of Effie, or do you also know what is the yes? What does the yes mean? Let me give you the ability to unmute. So you can maybe unmute and say something so that I can see. Can I also use VMware? No, it actually works with VirtualBox. It actually works with VirtualBox, Mr. Robot. And you can see it's very specific on the version. It's very specific on the version because of the version of the ENSP2. Also, the image file is also up. So all the 3 files you need are up. I don't need to tell you to where to get. Do I really need to upload for you or I make work easier for you? I go and upload also Wireshark and then pick up for you. What was there any other application that I missed? Oh, Kenya, sorry. Why did you choose to restart? Anyways, Dennis, you're asking about TNSP for Mac. Let's see where it is. So you can see currently ENSP only supports the Windows operating system. You can use a Windows virtual machine on the Mac. So what you can do, I also have a Mac. You can use VMware Fusion, install Windows on it, then get ENSP inside the Windows. Same case for Linux. You can still do that. If you have trouble doing that, you can tell me. The VTW, Denzel. I think I just mentioned this. I've just mentioned this. So just open. So this VFW, it's a firewall image file. You cannot run a firewall without the image. You can see that is why you can see it's telling me device has not been started because I haven't started it. So what I just need to do when I come here, I right click on it, then I click on start. So once it's finished, and this will not work if you haven't set up. And there's a process for it. There's a lab guide. I hope you got the lab guide, but I can upload it also on that side. I can do it for you. There's a lab guide, Huawei. I think this is the lab guide. So it is starting. So let me get you the lab guide here. If I open it, it can help you do a number of things on it, which is fine. So there's also a firewall configuration. I can download this, and you can also download this. Let me also upload it also for you. So this is the lab guide. You can do a number of things on it. So you can see, you can look at basic firewall configurations, name firewalls. For example, topology for basic firewall, you can have a COM port, Ethernet, and it is that. Log into the firewall through the default, perform basic configurations. So this is what, log into the firewall. So establish connection and power on all device, log in through the console port, telnet or SSH. For details, see experiment 1. I can look at experiment 1 and follow it up through and see how it really works. But let me show you something on this configuration. Let me extract it. Yeah, I've put it, Sharon, I've put it in the shared, the shared what? The shared Google Drive. So I can see the adapter is missing. I don't know what that means, but let me open the topology first. So this is a topology that had been created by another instructor, but it is a very good basic topology. So do you see this? Is a cloud, it is starting up, I think it is. So there's 2 PCs, they're all connected to a switch. You can see, these are switch 1 and a switch 2. The first interface is connected to the firewall. The second interface is connected to the host is connected to the second interface. What do you mean when you say refresh Google Drive? Okay. Oh, okay. I think you'll see it. Yeah. So you see this is the topology, and you're going to get that. So what happens is when I start, we can select this, how you do it. You select all the devices, then you right click, then you say start. It might take a lot. So you need a very good, you need a laptop with good RAM, 8 to 16 GB RAM. Otherwise, you'll be headed for disaster. So like mine is a 16 GB RAM for it has 16 GB RAM. So it's starting. So when you look at that topology, you should be able to see, can you really ping this? For example, if I open this, you see the IP address is 192.168.30.30. So these are static configuration. You can come and set up a basic configuration of a PC here. You can run a ping. So for example, this is 1010. So let me see whether I can ping 1010 from here. So you can see I'm not getting to it. Not getting to it. But you can see, if you see very well, these ones have not yet started. You see, you are seeing these ones, this one is now green, but these ones are still red. 4 GB RAM, it is actually struggling. It's actually struggling. I'm sure of it. So I hope, Dennis, you've seen the workaround for getting NSP onto your MacBook. I hope you have VMware Fusion. If you don't have VMware Fusion, you can tell me. I can show you how you can get it. You can get it for free, VMware Fusion. I revoked which link? Cheruyot. That is, I'm trying to check the chat right now. Oh, Adrian is saying I try to use AR router. See if it starts. Which AR router? Personally, I think it is working. It's about to start it, this router. So don't do things that you're seeing me do if you don't have enough RAM. You'll be surprised. Yep. Ah, 16 GB mtatoa wapi mazi? 16 GB unaweza pata. You can get these things. Your computer science or IT gurus, you need to have a laptop that is not complaining. Anyway, you can see now my Nini is working. They're all green somehow. So let's try to ping again. There's a timeout. Then I think after it has learned, it will now go. Do you see some timeouts, 2 timeouts? Then it start working. So it was learning. There was no, you remember the process. Then by now, there's not going to be any kind of issues. So let's look at those configurations. Do you remember how to look at the system view? Don't know, what was the command? So you remember in the other side, you usually say enable, but I don't know, here you usually say, so you can see change status to app. So you can see something there. Login, can see, what was this? What was this? What was this? What was this? So let's look at the different types of view under the firewall first. So let's log in. Obviously, remember the password, admin, then capital A, DIMN at 123. Did I change it? I think it, okay. Oh, you can see it is here. Username, admin, and admin at 123. If I'm talking about this part, you can see it here. Let me see that. So it says it has failed. So let me try the other password, admin at 321. So it has worked. It has worked. Good. So you can see this is a user view. This is a user view. What did we say? What is the command we put for the other types of views? System view, right? System view. Let's try that. Sorry. View. So you can see I've entered system view. The command has changed from angle brackets. I hope somebody can see. Let me just zoom in. Najua macho in. Okay, I'm trying to avoid the Kiswahili now that I was told. I know eyes are not really that good this time. Okay, which other view can we go? Yes, Denzel, it sometimes get crazy. It's already time. So what I'll do is, I know we not covered a number of concepts and some threats on the other side. Please make sure you read them. We're going to do a discussion for 30 minutes for tomorrow's session and ask each other for what was there in the slides. But I wanted to really ensure that I use this second part of the class to show you how to get these this ENSP working and you to be able to do this. So there was another view, which was the other view. There was an interface view, right? So the slides, oh, Murugi, somebody share the Google Drive, somebody share the WhatsApp group link, somebody share, please share those things. You've already shared them. I don't want to repeat and repeat and repeat those kind of things. So what do you want me to share in the group? Maybe I would share. So there's another view. Let's open the slides. Let me open it on this other side. So for example, I can try to run this. Let me see whether it's going to work. So are we having, what is the name of our interfaces? GE1000. Everything has been shared on the Google Drive, please. So you can see you can even use capture data. That is why you need Wireshark. So for example, I can capture, maybe I can capture one that is going through 00. So you can see it's loading Wireshark. So you can see, you try to follow it up. You can see this. So you can see even the costs. So ready to load capture. So let me just do a ping again. So let's look at Wireshark. So do you see what has happened here? There was a ping. You can see. Let me maximize this. So do you see what has happened? I can do another one. So you can see there's also a spanning tree. There's always trying to learn. There's always trying to learn. Let me do it again on this. As I do it here, you should expect another ping if I run the ping. So do you see the pings appearing? The packets are being captured within Wireshark, and you can see how it is showing. And you can even try to see whether you can try to make out and capture a packet and see, because these has a meaning, and try to see. If you also, you can see the source is what? The source is 1010 and the destination is going to 3030. So if you look at this, what is the configuration of this? This one is 3030. So you can see the one is 3030. If I do the ping from this side, so I'll still show you how to build this topology from scratch. Don't worry. So if I do that and I'm doing a capture, look at, you see the source is now 3030 and the destination is 1010. The source is 3030 and it is going back. The reply, is that the reply? Yes. The request is coming from 1010 going to 3030. You can see that is, I can quit without saving. Yeah, so this is a trust zone, and you're going to see that through the firewall configuration. This is a trust zone, and this is an untrusted zone, and they also have something going on to the cloud. And you'll be able to try to see if you try to do some configurations and look at the topology itself. Can you try to access some of the things here on this other side? And you see, and you can see all of this is under 10. This one is under 30. So I hope you can, if you are able to run this and get this configuration running, it started this. I think this is also, you can go to system view and see it. So this, I'm sure, is the most interesting part, practical stuff, practical stuff. So you can see, I've already gotten to the system view. You can run other commands, look at the lab guide. The lab guide is always helpful in times of anything. You can just run up and look for router configuration. Denzel, you're saying you're not hearing anything. I hope you can hear me. So this is Firewall hot standby. Yes, I know it is more interesting. I'm also a more hands-on person. So you can see log into a network device. You can see this is a router. How do you do that? Console, hardware, blah, blah, blah. Engineers. Blah. Once you hear physical, you can see system view, interface, gigabit, Ethernet 1. You can do this. I don't know if this one will work. Let's see. So this one is, it might not be having that interface. So you'll have to check on the default. So let's look at, you can look at the settings. So you can see that is, you can be able to see that. You can see, even you can look at the COM port is 2003. This is how it would look physically in terms of that router. So you can still use the command. You can start like that. You can see, I can be able to see some of the commands that I can run. Still see. There are so many. So I can just cancel it out. And maybe I can say interface. Then I put a question mark. And see, I can say interface, Ethernet interface. I can look at some. Do you remember the help that I can do? I can just even use int. You can see it has already done. If there are no, if I say interface V and I do a tab, you see I can see template VLAN. I'm pressing tab continuously. So you can see it is repeating. So you can see that is, so those are some of the commands you can run. We'll do more on this. We'll do another lab on this, but it's something you can go back between the firewall, the router. Very nice. And see that. So you can get out of the system view and go back to the user view by typing quit. You can see there you have there. You can look at the commands you can run under system view using the question mark. And you can do, maybe let's say, I can say check. I can say check. Then I can say check. If it needs information, I can just do this. So I can say check startup. Very easy. You know, these things are easy. So startup software has failed, fitted, slave board is not existing. So you can see I've been able to see how it has worked. So I think these are good. So since I have a number of participants who would want to go home the same way I would want to go home, although I'm already home, and I'm sure some of you dropped off, and I think I'm recording. I don't want this to be too long. So I think we can leave it at that. I wish, can it be possible that we log in earlier tomorrow, maybe around 2:30, and start at 2:30 and do something, if possible? Maybe we can do that so that we look at those slides faster, then get to something practical. Yeah, I think that would be fine. So if you haven't filled the attendance, let me just share it one more time for those who had not filled it. It's on day one. I can share it with you. So you can fill it if you had not filled it. So let's see each other tomorrow. Unless there's anything, I'll stop recording, but I'll still be around to answer any questions for those who want to ask me any questions. So let me stop recording. See you tomorrow for day 3. This life is going faster than I could have ever thought. So let me stop recording.